Here we are. First question, that is, what are static charges? So these static charges, when we deal with, that can be charges at rest. When charges are at rest, how they can be responsible for electricity? For that, we have to make these static charges free. Where these static charges actually exist? They exist in the bodies which do not have free electrons. Which bodies do not have free electrons? Actually, they are insulators. All insulators have tightly bound electrons. Again, another question which is there, how they can be freed? So for making them free, we have to do certain amount of work. As per work energy principle, this work can be converted into form of energy. That energy might have been taken up by the charges to dominate electrostatic force of attraction. Here, from where and for what work has to be done? Because already charges are at rest. For that, we have to rub the bodies. These bodies, when they are rubbed together, there exists friction. So to overcome the friction, we have to do the work. Now the work, I have already explained, will be converted into energy. And with the work it is converted into energy, that will be taken up by the electrons which are tightly bound in the outermost shell of atoms of the given material. Now, these electrons, taking that energy, they become free. But the energy which has been supplied, it is only sufficient to make them free, but they cannot flow. So when the charges cannot flow, how the electricity can be imagined? So there, these charges cannot flow, but they can be transferred. What is the basic means of transference there? The two bodies which we have taken, that is the basic means of transference. The two bodies should be in such a way that one should have electron affinity highest, another should have electron affinity lowest. In that scenario, when these electrons are made free, the electrons from the body with low affinity moves towards the body of high affinity, making the body electronegative. Another body which has lost the electron, that will become electropositive. Obviously, one body has gained, another body has lost. When this losing and gaining game is played between the charges, there is always a type of push and pull developed. This push and pull, we know as per definition of force, will have a type of force experienced. Now, in which direction they get transferred? Higher affinity body to from lower affinity body to higher affinity body, from higher affinity body to lower affinity body. That is the direction, means electropositive body will become when it loses the electron, electronegative body will become when it gains the electron. Then, how can a charge be defined? So, up till these questions, we have just clarified that charges are there. But how we can define a charge? So, the charge can be defined as a part of a material body which can respond to the push and pull type of forces, making a characteristic quality of attraction and repulsion. Hence, these electrons and the nuclear part of atom, when they start to show additional properties of attraction and repulsion. When they start to respond for attraction and repulsion, we can say that we have defined charge. With a charge of fundamental quantity? No. It cannot be a fundamental quantity because it has no unique identity of itself. It can move from one body, it can go to another body. Its unit, SI unit. SI unit is coulomb. So the charge can be measured in coulomb. All these charges are having some special characteristics property, and these special characteristics property make them more and more specific, more and more supportive for applicative approach. There, first one, that is conservative. All charges have conservative natures. That means there is no source or sink. They can neither be created nor be destroyed. Then what happens? They can be transferred from one body to another body. But the total sum of charge always remains constant. Again, one more question is there, that is charges are scalar or vector. As we know, scalar quantities are those which require magnitude as well as direction, but vector quantities are those which require magnitude as well as direction. These charges do not possess any type of directive approach. They can move randomly, they can align randomly, but that they do not have their own direction. So they are generally scalar by nature. Being scalar by nature, they have a special addition methods. They can be added only algebraically. We cannot apply vector laws of addition because these charges do not have vector nature. Already I have told that these charges have developed a loser and gainer game, and because of that always there is push and pull scenario existing between them. Because of that they are supported by attractive and repulsive forces. Hence, we are having two nature of forces, two types of forces. These two types of forces are one positive, one negative. When the two same type of charges are brought together, they will push and they will be showing repulsive nature, and when the opposite type of charges are brought closer, they can always pull and they show attractive nature. One specific criteria, that is quantization. What is the need of quantization here? The need of quantization arises because charges cannot move in fractions. And now we have understood the charges have to be transferred. And if they have to be transferred, they cannot be transferred in fractions. They transfer as integral multiple of elementary charges. That means they can be transferred as a quanta. What is the value of a quanta? Quanta is nothing, it is plus minus Ne. Why plus minus Ne? Plus minus Ne because the body which is going to gain the electron, it will be getting negatively charged, and the total charge on that negatively charged body will be minus Ne, and the body which is going to lose the charge, it will be getting positivity, and because of that the total charge on that will become plus Ne. But if no charges are existing on the body, total charge of a body can be 0, or if the body is not charged, then also total charge in the body is 0. So you can justify, you can get a justification here that charges can be transferred from one body to another body in form of plus minus any, and this phenomena is called quantization. Here E, it is basic elementary smallest positive value of a charge which exists, that is charge on an electron. Value is 1.6 into 10 to the power minus 19 coulomb. But this quantization condition is very specific. Because of this quantization only, we are getting positive charges, we are getting negative charges, we are getting attractive natures, we are getting repulsive natures, and transformation of charges exist there. Also, I have already told you the charges cannot move, they can be transferred. One more criteria is there, they can be induced. How? So, we can have one more part, that is charges can be induced without being contact. If a charged body is brought near a neutral body, then all the opposite nature charges move towards the rod which is oppositely charged. So, from a distance also the charges can be induced. This is all for today's video. Please do like, share and subscribe. Put your feedback and questions in comment box below. Goodbye.